Welcome to The Explainer. Today, we're diving into something that trips up a ton of developers. How do you get your beautiful, clean Java objects to play nicely with the rigid, structured world of database tables? So let's just get right into it. There's this fancy term for the problem, object relational impedance mismatch. But really, all it means is that your Java code and your database kind of speak different languages. They just don't naturally understand each other. So, how do we become the universal translator without writing tons and tons of boring, repetitive code? Well, that's where these two heavyweights come in, JPA and Hibernate. The easiest way to think about it is this. JPA is the architectural blueprint. It's the set of rules for how you describe the mapping. Hibernate is the master builder that takes your blueprints and actually constructs everything for you. It does all the heavy lifting so you can stop translating and start designing. So where do we even begin? Let's start with the absolute basics, the foundational annotations you're going to use all the time to tell Hibernate how to handle just a single simple object. Everything, and I mean everything, starts with @entity. This one little annotation is like planting a flag on your Java class. It's you shouting to Hibernate, hey, this class is important. I want you to manage it and turn it into a database table. It's the simple on switch for the whole process. Now, @entity gets you in the game, but sometimes you want to be a little more specific. By default, Hibernate might name the table after your class, maybe product with a capital P. But most database folks prefer lowercase with plurals, like products. That's exactly what @table is for. It gives you explicit control to name things just right, keeping your database schema clean and conventional. Okay, every table in existence needs a primary key, that one unique ID for every single row. The @ID annotation is how you mark which field in your class gets that special job. But let's be real, who wants to manually assign IDs all day? Nobody. That's why we almost always pair it with @generated valued, which tells Hibernate, hey, don't worry about this, let the database handle it. And here we see the most popular kid on the block, generation type identity. This is basically you telling Hibernate to just use the database's built-in auto-increment feature. Every time we save a new course, the database just gives it the next available number. It's simple, it's efficient, and we can totally forget about managing IDs ourselves. It's great. So what about all the other fields? You know, the names, the descriptions, the prices. For those, @column is your precision tool. Hibernate makes some pretty good guesses on its own, but this annotation is your control panel. You can change the column name, say it can't be null, limit the length of a string. You get to define the exact rules for your data. All right, listen up, because this is a huge pro tip for mapping Java enums. You've basically got two choices. Ordinal saves it as a number, 0, 1, 2, and string saves its actual name. And let me tell you, ordinal is a trap. If you ever reorder the items in your enum, you will silently break all your data. String, on the other hand, is safe, it's readable, and it just works. Trust me on this one, always use enum type string. Okay, so mapping single fields? Check. But life isn't always that simple, is it? What about properties that are collections of things? Like a list of tags on a blog post, or a set of phone numbers for a single user. Let's see how Hibernate tackles that. The tool for this job is the @element collection annotation. Think about it. A single database column can't really hold a whole list of items. So what Hibernate does is kind of brilliant. It creates a completely separate table just to hold that collection and then links every entry back to the original object. This example just lays it all out perfectly. Our user has a set of email addresses. So with these annotations, Hibernate goes and creates a whole new table, which we've named user emails. That table is going to have two simple columns, a user ID to know which user it belongs to, and an email address column to hold the actual email. And just like that, you've modeled a one-to-many relationship with simple strings. Now for the main event. This is where object relational mapping, ORM, really truly shows its power. How do we build a bridge between two totally different entities? You know, like an author and all of their books? On the author side, it's pretty intuitive. We declare a list of books and use the @one-to-many annotation. One author, many books. Makes sense. But the most important detail here, the part you cannot forget, is mapped by equals author. This is crucial. It's telling Hibernate, hey, I'm not in charge of this relationship. The real connection, The foreign key is being managed over on the book side. And here we are on the book side completing the circuit. The @many-to-one annotation says, yep, many of us books can belong to one author. And because this is the owning side of the relationship, this is where we define the physical connection. We use @join column to tell Hibernate, okay, go ahead and create a column in the books table, call it author ID, and that's where you'll store the ID of the author. The link is now complete, but what about when things get even messier? When many things can relate to many other things? The classic example is students and courses. A student can take many courses, and a course can have many students. For this, we use @many-to-many. And Hibernate's solution is to create a third table right in the middle, a join table, whose only job is to store pairs of student IDs and course IDs, basically tracking every single connection.
All right, so you're feeling pretty good right now, right? You're mapping entities, building relationships. You've got this. But wait. There's a hidden performance trap that can sneak up on you and just cripple your application. It's called the N+1 query problem, and pretty much everyone makes this mistake at least once. So here's how this trap gets sprung. It looks so innocent. First, you fetch a list of all your authors. That's one query. So far, so good. But then you start to loop through that list. When you try to access the books for the first author, boom, Hibernate fires a second query. Then for the next author, boom, a third query, and on it goes. If you have 100 authors, you've just hammered your database with 101 separate requests. It's a silent killer.
So how do we fix this? It all comes down to understanding lazy versus eager loading. For collections, the default is lazy. It's lazy because it waits until the very last second to fetch the data, which is what causes our N+1 problem. The alternative, eager, fetches everything all at once with a big join. That sounds like an easy fix, but it can also be a performance killer if it fetches massive amounts of data you don't even need. The real pro move? Stick with lazy by default, and when you see an N+1 problem, solve it very specifically with a special query called a join fetch.
So let's take a breath and recap. We have covered a ton of ground here, from basic mapping and relationships all the way to nasty performance traps. Let's pull it all together and just look at the powerful set of tools we've assembled.
Just look at this toolkit you have now. You can define any class as an entity with a primary ID. You can use @column to forge all the fine-grained details. You know the safe way to handle enums. You can build out complex structures with element collection and create powerful links with one-to-many, all while using lazy fetching to keep your applications snappy. By getting a handle on these core concepts, you've really leveled up. You're not just mapping fields anymore. You're now a data architect, thinking about efficiency, relationships, and how to build things that last. You have the power to translate complex business logic into an elegant, robust database structure. So with these blueprints and tools in your hand, what's the biggest challenge you're ready to tackle next?